Good morning, I am Jimmy Thomas, Assistant Professor, Department of Biomedical Engineering, Excel Engineering College. Now I am going to take a lecture on PN junction diode. So already we all know that what is a P-type material and what is an N-type material. So both these type of materials like P-type or N-type, these made up of a process called as doping to semiconductor material. So we have heard about semiconductor materials like silicon and germanium. In order to increase the conductivity of these semiconductors, we are adding some type of impurities. That process is called as doping. So we can add two types of impurities basically. First one is P-type impurity and second one is N-type impurity or pentavalent impurity and trivalent impurity. If we are adding pentavalent impurity, what is happening is that in order to form the covalent bond between silicon and this pentavalent impurity, it will be using a 4 electrons. Remaining 1 electron will be free for conduction, so that the conductor or charge carrier will be a free electron. That is all pentavalent impurity, and charge carrier is negative electron, so that the material is called as N-type material. Next is type of P-type material, where we are using trivalent impurities. The property of trivalent impurity is that it is having 3 valence electrons. As it is incorporating or as it is involving in covalent bond with silicon, it is having only 3 electrons to share. So there will be a vacancy of 1 electron. That vacancy of 1 electron is called as holes. Holes are assumed to be having a positive charge. So that material is called as P-type material. So we completed about what is a P-type material and what is an N-type material. Now we are going to discuss about PN junction diode. Basically the definition for a PN junction diode is that it is a PN junction device. PN junction device means it is a combination of P-type material as well as N-type material, and when they are combining together there will be a junction formed in between. So it is a P and N-type material combined together, and it is carrying current in only one direction. That is a property of a PN junction diode, and it is also called as crystal diode. So now we are going to discuss about the structure of a PN junction diode. As I already told that it is a combination of P-type as well as N-type material. So P-type material, we know that P-type material is formed from doping of trivalent impurity. That means a vacancy is there, holes will be there. So we are considering the majority charge carrier as holes. Okay. Then charge of the holes are assumed to be positive. Next step, when we are considering the minority charge carriers in P-type material, minority charge carriers will be electrons that is having a negative charge, and also negative acceptor ions will be present in the P-type material. Moving to N-type material, majority charge carriers will be electrons that is having negative charge, and also minority charge carriers is holes that is having positive charge, and also positive donor ions will be present in the N-type material. Next step, why the minority charge carriers are present? The formation of minority charge carriers will be due to a process called as thermal generation or thermal breakdown of covalent bond. The process is that when the impurities like P-type impurity or N-type impurity is forming covalent bond between silicon or germanium semiconductor, when temperature increases, there is a possibility to break the covalent bonds. When the bond is breaking, there will be formation of electron hole pairs. That means by breaking the covalent bond, one electron as well as one hole is formed. So when you are considering the P-type material, when a covalent bond is breaking, there is a possibility of one hole as well as one electron. The hole is considered along with majority charge carrier, and the electron is considered as minority charge carrier. Then moving to N-type material, there is also when temperature increases, there is a possibility of breakage of covalent bond. So one hole is present and also one electron will be formed. So this electron is we are considering together along with the majority charge carriers, and we are considering the holes as minority charge carriers. These are the structure of P-type and N-type material. Now when we are combining these materials together, it will be forming a PN junction diode. Since the P-type material is having positive charge carriers, and the terminal we are taking out from the P-type material, we are naming it as anode, that is having positive charge. Then one terminal we are taking out from the cathode, that is having N-type material having negative charge, we are naming it as cathode, represented by letter K. Now we are going to discuss about the structure of a PN junction when no external bias or when no external voltage is given. That means one p-type material is there and one n-type material is there. Also we know the structure. P-type means holes are there and also acceptor ions will be there. Negative acceptor ions will be there. The property of the negative acceptor ions is that they are immobile in nature. Immobile in nature means they are not able to move. Similarly in n-type material, positive donor ions are there. They are also immobile in nature. They are not having the capability of taking movement. So we are taking or considering the p-type material means holes are there, negative acceptor ions are there and also minority is there. Then here it is positive donor ions, negative electrons and also minority holes will be there. While it is in normal condition or when no bias is given, there is a possibility that the holes have the capability to attract towards negative electrons and also negative electrons from n-type will be attracted towards positive material or positive holes. Then what is happening is that these electrons will be coming to p-type material and combining with these holes. Then these holes will be moving to n-type material and combining with these electrons. That means recombination of electrons and holes will be taking place. Then the result, what is output of this recombination is that at the particular area of diffusion or the particular area of recombination, the remaining particles will be only immobile charge carriers. Remaining all the holes and electrons will be getting cancelled. At the barrier or at the junction, only immobile charge carriers will be there. Then you have one doubt, that means it will be moving towards N region and this positive will be moving towards P region, because they are immobile in nature means they will not be taking any movement, so that this region will be filled of only negative charge carrier, negative acceptor ions and positive donor ions. Next what is happening is that further remaining all electrons are here and remaining holes are there, but they don't have the ability to come here because they formed a barrier here. This positive donor ions and negative acceptor ions formed a barrier here, so that the remaining holes cannot diffuse to N region and remaining electrons cannot diffuse to P region. So that due to the presence of these immobile charge carriers, there is a barrier formed in between the junction. That region is called as a depletion region, or it is also called as a space charge region. So this property of this space charge region is that they will be generating an electric field. Property of the electric field is that this electric field will be forcing the electron to stay here itself and the holes to stay here itself. They will not be crossing the junction. So that the potential is also called as barrier potential or space charge potential. So we know that two types of semiconductors, silicon semiconductor and germanium semiconductor. For silicon semiconductor, the barrier potential is 0.7 volt, and also for the germanium semiconductor, the value is 0.3 volt. Next what we are going to discuss is that the biasing of a PN junction diode. So while discussing about the biasing of a PN junction diode, there are two types of biasing. First one is forward biasing and second one is reverse biasing. So while discussing about forward biasing, we have to know the polarity of the power supply. Biasing means one external power supply we are providing to the diode. Already we know that P-type material is positive in nature, N-type material is negative in nature due to electrons. It is positive in nature due to presence of holes. And in forward bias, the property of the biasing or property of the voltage source is that we are connecting the positive terminal of the voltage to P-type and negative terminal of the voltage to N-type. That means P to P connection and N to N connection. So when we are considering this biasing or forward biasing, we know that in P-type material holes are present and in N-type material electrons are present. Charge of electron is negative and charge of holes is positive. So consider the power supply. Here what polarity is having? We are having negative polarity. So two like charges coming together means there is a possibility of repulsion. So here two like charges, positive holes as well as positive terminal. So there is a possibility of repulsion. Here also negative polarity and negative charges, there is a possibility of repulsion. So what is happening is that from this terminal or from this positive voltage terminal, the holes will be repelling to the other direction or repelling to N direction. Here what is happening is that the negative electrons from this side will be repelling to the P direction. So what is happening? Initially this much is the depletion region. Initially the depletion region formed by immobile charge carriers are wider. So when these charge carriers are moving in opposite direction means they will press the depletion region together, or they will compress the depletion region. So as a result of this compression or this forcing of this depletion region, what is happening is that the width of the depletion region will be reducing. So we are increasing the voltage. As on increasing the voltage in this terminal, the depletion region width will be reducing and that will be cancelling. So when the depletion region is cancelled or this depletion region is vanished means what is happening is that the holes will be moving from P to N region and electrons will be moving from N to P region. As a result of the movement of these holes and electrons, there will be a flow of current. So flow of current will be from P region to N region. That is similar to the direction of holes and opposite to the direction of electrons. That is about forward bias. That means key point is that during forward bias, depletion region width is decreasing and also it will be conducting current. Next is reverse bias. Reverse bias is exactly opposite to that of forward bias. That means we are considering a P and N region. Then negative terminal of the voltage is connected to P and positive terminal of the voltage is connected to N region. That means it will be forming a negative bias. So we are considering the charge carriers. In P we are having holes and in N we are having electrons. So what will be the nature of movement? Here holes will be attracted towards the negative charge and electron will be attracted towards the positive charge. So that electrons and holes will be moving away from the depletion region. So holes and electrons moving away from the depletion region, what is happening is that the depletion region width will be increasing. As the depletion region width will be increasing means the holes cannot take a movement from here to here and also electrons cannot take a movement from N to P. That means charge carriers are not crossing the junction. As the charge carriers are not crossing the junction means no current will be flowing through the junction. No current will be flowing through the junction during reverse bias. So two parameters or two conditions are there. Forward bias, depletion region width decreases, conduct current. Reverse bias, then voltage increases, bias depletion region width increases and no current will be flowing. But one condition is that as we are increasing the reverse bias voltage again and again, it will be leading to the breakage of depletion region. That means reverse bias voltage we are further increasing to a higher value, there is a possibility of breakage of depletion region. So after the breakage of this depletion region, current will be flowing. Okay. So the content is that in PN junction diode, current will be flowing in forward bias mode only. In reverse bias mode, current will not be flowing. Only after the breakage of this depletion region, current will be randomly increasing to other values. So this is all about the construction and biasing of a PN junction diode.